All right, so today we're going to be talking about areas and volumes and how we can convert between all of them. So first up, just a couple of definitions here. As we should know all the way back from grade school, area is equal to length times width, and then volumes are going to be equal to length times width times height. Or we could also write this as, the area times the height. Now, of course, we could also call this depth or whatever else you want to refer to it. All right. Now, when we're talking about, areas length times width, of course, length and width have units of distance. So that means that the units on this are going to be something in the order of distance squared. And if we're talking about volumes over here, this is going to be distance times distance times distance. So the units on this are going to be distance cubed. All right, now when we're talking about, distance squared, distance cubed, this means that areas are, of course, going to have units of meters squared or feet squared or square inches and along those lines. Volumes are going to have units of, cubic meters, cubic feet, cubic centimeters. Also, we'll be seeing liters and milliliters, but those are also related to distance cubed as well. All right, now when we're talking about areas here, we just want to start off with something very simple. So here is a little square I'm drawing, and we're going to say that each side of this has a length of 1 foot. All right, so we're just trying to use some units that we're used to. So of course we're trying to figure out the area, and this is just going to be equal to 1 foot times 1 foot, which is just going to be 1 square foot. All right, and that's basically the little distance of the tiles you usually see on the floors around here. Now let's say we want to go here and figure out, well, what is 1 square foot in inches? Now this is where you have to be very careful, because if you remember, each foot here has 12 inches in it. That's going to be 12 inches. So that means that each one of these we're going to divide up into 12 blocks each.
Right, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 12 that way, and then another one's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that way.
All right, so again, not that accurate, but either way, you can basically see here we have 12 by 12. And if you go through and actually count all of these, which I'm not going to do, but you're going to wind up here with 12 inches times 12 inches. So that's going to be 144 square inches. So if you go through and count this, you should find out there are 144 little boxes on this thing. So this is the very important point that you have to be very careful of, and this is going to be for areas and volumes, is that right here, 1 square foot does not equal 12 square inches. All right, and this is also going to be, we're going to be seeing here, if we're dealing with a square meter, that's not going to be 100 square centimeters, or cubic meters, not 100 cubic centimeters. So this is where we have to just be very careful, is that when we're doing these conversions, we have to remember to square and cube these things. So when we're dealing with these, now how are we going to convert this, instead of going through and actually writing all this out explicitly every time, is that we can, just use these regular conversion factors that we're familiar with. So what we're going to do here is, let's say we have here 1 square foot, and now I have, in this case, 12 inches per foot. But then I'm squaring the entire thing. And this is the important thing. It's always important just to put these parentheses around here, so remember you're squaring everything in the parentheses and not just the inches or the feet over here. So if we write this out, that's going to be 1 square foot is 144. Remember to square everything. Square inches. And then on the bottom, that's also going to be 1 squared, which is just 1. And then the foot squared. Squared. Now right here what happens, we have square feet. These cancel out with the square feet. And of course we're left with the 144 square inches like we expect. Okay. Very similarly, if I were to go here and make a box which is 1 foot on each side, then very easily the volume of this is just going to be 1 foot times 1 foot times 1 foot, which is just going to be 1 cubic foot. And very simply, just using the same technique we had up here, that's going to be 1 cubic foot is now 12 inches per foot cubed, which if we just take 12 cubed, that's actually just going to equal 1728 cubic inches. So when we're dealing with these, the volume, when we square and cube these things, these numbers can get very, very big, very, very fast. Okay, so that's when we just have to be careful. Again, remember to cube. This is 12 cubed, which is going to work right into there. All right. So as we can just look at some other examples here, now we can use the more metric ones that we're going to be familiar with. Let's say we're taking here 13 cubic meters and we want to convert this into cubic centimeters. So this is going to work out to be 13 cubic meters. And then our conversion here is that every centimeter is 10 to the minus 2 meters. And here we cube that. So this is going to be 13 cubic meters times 1 cubic centimeter. So that's 1 cubed times centimeter cubed divided by, now here remember our laws for the exponentials, that's 10 to the minus 2 cubed, so that's 10 to the minus 6th, and then that's going to be meters cubed. And of course 1 over 10 to the minus 6 is going to equal 10 to the plus 6, so that's going to be 13 times 10 to the 6th cubic centimeters. All right, so the cubic meters, these cancel out, and you're left there with cubic centimeters. Now on the flip side, let's just say we want to go from something small to the bigger one. So let's say I'm dealing here with 15 cubic millimeters in this case. And I want to figure out how many cubic meters that actually is. Well, here's my 15 cubic millimeters. And then on the bottom here, I know that 1 millimeter is going to be 10 to the minus 3 meters. Again, cubing all of this. So 10 to the minus 3 cubed is going to be 10 to the minus 9. And there's no flipping involved in this case. So that's going to be 15 times 10 to the minus 9 cubic meters. Again, noticing this canceled out with that down there. Now when you're dealing with these, what can generally happen is somebody is going to put this on the wrong side. If we're taking something that's fairly big and going into something that's fairly small, we're going to have a lot of them, right? So you're going to have a lot of these small things filling up the big thing. On the other side, the small thing over here is not going to take up a lot of the big thing. It's going to take up a very, very small fraction of that. Now, let's say these were all just one step. We just did one little conversion. But what if I have to actually do 2 steps? I want to go, let's say, from millimeters to centimeters. And then I have to use an intermediate. And basically, you just daisy chain this. You just do one multiplication after another, as many as you need to get what you actually do need in those cases. So let's say in this case, we're now going to be looking at 12 square kilometers, and we want to go to square centimeters, sorry. All right, so we're going to be dealing with areas. So these were volumes that we were dealing with before, and we were cubing these. In this case, this is an area, so we're just going to be squaring this. So here, my 12 square kilometers. So first thing we want to do is convert this into square meters. So I have 10 to the 3rd meters per 1 kilometer. And now that's going to be squared. And then I want to convert this into centimeters. So 1 centimeter is 10 to the minus 2 meters. Again, square that. And just to write out explicitly what we're actually having here, so that's going to be 12 square kilometers. And then 10 to the 3rd squared is going to be 10 to the 6th square meters divided by 1 kilometer squared. And then over here, I'm going to have 1 square centimeter divided by 10 to the minus 2 square, that's 10 to the minus 4 square meters. And we can look at our units, square kilometers, these go away, square meters go away, and I'm going to be left here with just square kilometers. So this is just going to work out to be 12 times 10 to the 6th times, and I have 1 over 10 to the minus 4, so that's going to be 10 to the plus 4. So that's going to equal 12 times 10 to the 10th square centimeters in that case. Now, let's say for whatever reason we actually just want to convert this into square feet. Well, how would we arrive at doing that? Well, let's just do basically the same thing, okay? So let's say we're starting over here. We want to get our 12 square kilometers to square feet. Now, you can just do this in one large equation, all right? You don't have to, break this apart and then do each little calculation, write down your answer all the way halfway through. You can just write this out as one equation. It's a lot easier than trying to, do it in, 10 separate different little steps here. So we're just going to start out the exact same way that, we had right here with the 12 kilometers and converting into centimeters. So we're going to start out the exact same way here. That's going to be 12 square kilometers. And again, our 10 meters or 1,000 meters per kilometer. And square that. And then here I have 1 centimeter per 10 to the minus 2 meters. Square that. And now we're at centimeters, so we can very easily convert this to inches. So I have here 1 inch is 2.54 centimeters. And then since I want to be in feet, I'm going to have here 1 foot is 12 inches. Oh, and don't forget, of course, I need to square each one of these, otherwise I'm going to be off. So this is very easy. Now you just have to plug and chug this stuff in there. So that's going to be 12 times 10 to the 3rd squared times 1 over 10 to the 4th, well, 1 over that squared, so this is going to be 10 to the 4th, so times 1 to the 4th. All right, and then I'm going to be dividing by 2.54 squared, and then dividing that by 12 squared. And we're going to get something which is very, very big, and just put this into scientific notation. So this is going to be equal to 1.29 blah, 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 times 10 to the 8th square feet. So that's basically when you're doing these equations, you just, put it one thing after another, whatever conversion factors you happen to need just to get to your final result that you're actually looking for. And if you need to, you could, just keep on doing this. So you're just multiplying one thing by the other. And the important thing we notice right here, notice like my square kilometers, cancel out with my square kilometers, my square meters, cancel out with my square meters, my square centimeters, cancel out with my square centimeters, my square inches, cancel out with these square inches, and I'm just going to be left here with square feet, which is what I want. So you can just keep on doing this as much as you actually need to. A very common unit we'll be using often in chemistry is the liter. So 1 decimeter is equal to 10 to the minus 1 meters. So this is one of those SI units. We don't really use it that much, but we do see it a little bit in chemistry. So the decimeter is 10 to the minus 1 meters. So if I look here at 1 cubic decimeter, so I cube that, that's going to be 10 to the minus 1 meters cubed. So that means that I have 1 cubic decimeter is 10 to the minus 3 cubic meters. This is what we know as 1 liter. All right, so this is a 1. So 1 liter. And this is a unit very, very commonly used in chemistry, mainly because, it's just very convenient to actually have these values around there. And we may also see this represented as, instead of 1 cubic decimeter or 1 liter is 10 to the minus 3 cubic meters, we might also see this represented as 1,000 liters is equal to 1 cubic meter. So this is also a very common way of writing this out. Another common unit that we will see is, of course, the milliliter. So 1 milliliter, which of course is going to be 1,000th or 10 to the minus 3 liters. Also very commonly we might just write this out as 1,000 milliliters is equal to 1 liter. So 1 milliliter is a very, very small unit, and 1 liter is a fairly big unit. Okay, so we've seen 1 liter bottles of soda, and 1 milliliter is just going to be a small fraction. It's literally just a couple of drops worth of this stuff. Now, as for the milliliter, if we want to look at this and figure out, well, how many cubic meters that is, so 1 milliliter is 10 to the minus 3 liters per milliliter, so that's just by definition. And from this other definition we have over here, we have 10 to the minus 3 cubic meters per liter. So my liters cancel out, my milliliters cancel out, and I'm just left here with cubic meters. So 10 to the minus 3 times 10 to the minus 3, that's going to be 10 to the minus 6th cubic meters. All right. Now, what is actually equal to 10 to the minus 6 cubic meters? Well, we're just going to see if we look here at what 1 cubic centimeter actually is. So this is 10 to the minus 2 meters per 1 centimeter. And I cube this, so 2 times 3, that's 10 to the minus 6. And no surprise, this is going to be 10 to the minus 6th cubic meters. So this is a very important relation that we will be seeing quite often, is that 1 milliliter is equal to 1 cubic centimeter. All right, so this is a very, very important relation. We'll just be seeing it's very, very useful when you're doing the conversions. You may also hear this referred to as 1 cc. cc just stands shorthand for cubic centimeter, and if you watch any of the medical shows, they may see, quick, the patient needs 20 cc's of, nameless drug, stat. So all that referring to is that cubic centimeters, and it's just a lot easier to say cc's in a medical environment when you need results fast rather than saying milliliters or cubic centimeters. So if you hear cc's, that's all they're actually referring to. A bottle which has 15 liters in it, then how many cubic centimeters are actually in there? Well, we can just easily do this. So I have here my 15 liters, and we know that there are 10 to the, for every milliliter, there are 10 to the minus 3 liters. And then we, of course, also know that there is 1 cubic centimeter per 1 milliliter. So, unsurprisingly, that's just going to be liters. My milliliters cancel out. So that's just going to be 15 times 10 to the third cubic centimeters. So, we can just use these same conversions that we've just seen up there. Okay, now let's say we're dealing with questions where we have mixed units. So they're all lengths, but they're different units. So one might be in square kilometers, the other thing might be in feet, and we're dealing with the volume, but how do we actually deal with these conversions? So let's look at Eagle Lake. Okay, so that's that one big lake, it's by Mankato, so you're probably a little bit familiar with it if you've explored the area at all. Well, if you look up the values for this, it has an area of 3.7 square kilometers and a depth of about around 9 feet. So we would just, let's say we want to figure out, well, what is the volume in liters? All right, so when we're going to be dealing with this, all we have to do, we have area times depth, or or height. So we just multiply these two together. That's going to give our volume. But then, of course, we just have to convert the rest of this stuff into units where we can actually get this converted into liters. And we can do that by basically converting my kilometers and my feet both into meters, and then those meters and those will have cubic meters, and then we can just convert the cubic meters into liters very easily. All right, so our volume is going to be 3.7 square kilometers. And then we have our 9 feet. Okay, and even though they're different units, we can easily multiply them together. And now we know that when we're dealing with a kilometer, that's going to be 10 to the third meters per 1 kilometer. And notice here, this is square kilometers, so that's going to be squared. And at this point I have square meters, so that's good. Now I can just deal here with my feet. So that's going to be 12 inches per foot. And there's no squaring because these have just units of length, so there's no squaring going on. And then we're going to multiply this by 2.54 centimeters per inch. So now my inches cancel out, I'm left with centimeters, and then I can very easily just convert my centimeters into meters. So that's going to be 10 to the minus 2 meters per 1 centimeter. And at this point, I'm going to have here meters times square meters. So then I can just do my conversion into, because that's going to be cubic meters for the whole thing, is that I will have here 10 to the third liters per cubic meter. So even though it's a fairly long and involved equation, it all works out. If we look here, my square kilometers, these cancel out. My feet go away, my inches go away, my centimeters go away, and then I'm going to have here meters and square meters. So that's going to cancel out with these cubic meters, and I'm just going to be left here with my liters for my 7 times 9 times 10 to the third squared times 12 times 2.54 times 10 to the minus 2 times 1,000. And we're going to get here that our volume for this lake is equal to 1.01 times 10 to the 10th liters. And that's basically it. Now, as for continuing on, if we're dealing with stuff that's in, gallons or cubic feet or cups or quarts, pints, whatever, all those conversion factors will just be given to you, so you don't have to worry about, memorizing those. But, here when we're dealing with the length-based units, this is where we just have to be very careful that when we're going to be converting this, that we're squaring the stuff. And definitely the things that I do never want to see, written down there are, the very bad things that, hopefully we won't do the mistakes is by saying, okay, well, 100 square centimeters is equal to 1 square meter. That's no. Or, we don't want to see something like, 10 to the 9th, 10 to the 9th square or cubic nanometers is equal to 1 cubic meter. Again, that's a big no. What we have to make sure that when we're dealing with these is that we cube the entire thing. So in reality, 10 to the 9th cubic meters, or cubic nanometers, if we look at this is going to be 10 to the minus 9th meters per nanometer. And if I cube that, 9 times 3, that's 27, plus 9, or negative 27, I should say, plus 9. So this is really going to work out to be 10 to the minus 18th cubic meters. All right, so you may think, well, that's a lot of cubic nanometers, but it really doesn't take up a heck of a lot of cubic meters. So that's actually a very, very small amount. So again, you have to just be very careful when you are dealing with these volume conversions here. All right, and I will stop it there.